This is the second in a series of videos on vector space classification. In this video, we will be discussing Rokio classification. Rokio classification is a method of calculating class boundaries in vector space. Before we go any further, we need to establish what a good boundary is. A good boundary between classes, which is sometimes called a decision boundary, is a boundary which has a high accuracy on unseen data that has not been used to train the classifier. Rokio classification is one method of drawing these boundaries. Rokio uses centroids to define the borders between classes. The centroid of a class is the vector average of its members. It is sometimes called the prototype of a class. The stars represent the centroids of the class of green circles and the class of purple squares. The centroid of class C is computed as the vector average or center of mass of its members, with the equation shown, where D subscript C is the set of documents in set D whose class is C. D is a member of that set of documents, and the normalized vector of that document is represented by vector VD. For this collection of documents, there are 3 classes. Each class has a centroid. The centroids in this video are going to be represented by space stations, centrally located inside each collection of planets. Just a reminder, planets represent documents in this series. The locations of the centroids are based on the positions of the training documents, as we said a moment ago. Let's try it with a new planet representing a piece of test data. This makes determining the correct class of a document easy. The document is assigned to the nearest centroid. The borders are similarly easy to define. A border between 2 classes is a line of points that are an exactly equal distance between the 2 centroids. Let's take a quick look at the algorithm for Rokio classification. To train a Rokio classifier, for each class Cj in set C, the set of all classes, assign to D all the documents in the set of training documents that are in the class Cj. Next, calculate the centroid for that class of documents by computing the vector average using the normalized vector for all documents in class J. This returns the set of centroids. When applying Rokio, you require the set of centroids and the document. It returns the nearest centroid to the given document. Rokio classification is a variation on Rokio relevance feedback. Rokio relevance feedback became popular in the 1970s and is used to improve the recall of queries. It uses the vector averages of relevant and non-relevant documents to modify the user's query and generate more accurate results. Rokio classification removes the query element of this process. In terms of time complexity, Rokio behaves similarly to naive Bayes. The training time scales linearly to the size of the document collection. However, Rokio does have one important flaw. Classes must be roughly spherical and ideally of similar density. Rokio does not account for distribution of data and can misclassify results if there's a lot of variation in density. Also, Rokio often misclassifies elements when a single class is distributed across more than one cluster. Let's look back at our planets. We are sorting them into 2 classes. For this, safe for a visit and definitely fatal. We have 2 space stations representing the centroids of each class. You might notice that the safe planets are spread out into two distinct clusters, with the centroid in the middle of those. Now, let's try to determine if that planet, our test case, is safe for a landing. You notice that it is closer to the dangerous planets than it is to the safe ones, but it is nearer to the centroid of the safe cluster. This means it will be incorrectly labeled as safe by a Rokio classifier. Sorry about that, explorers! Thank you for watching this video, and please check out the others in this series.